let's talk about homework last night. Let's see how we did. It's newer, so let's make sure we're good with it. So, what it was page 190. Is that right? So, I know I didn't.
I didn't get a lot of it. I didn't get like the second to last part.
Okay, we're gonna go over the whole thing. Is that cool? I'm not gonna mark it off. Well. Who you guys got tonight in football? Rust? Hey, yeah. Is it here or is it? Yeah. All right. Well, good luck and have fun. Let's see. What do we got? Problem number 1. We have line A, we have line B, we have line C. We have the points that are given for each. Yes? Could somebody tell me what slope they got for A, B, or C? And we'll get a slope for A. A, what do you got?
I got 2 over 1.
What?
No, I got 1.
You got what? What?
1.
Just 1? That's a 1?
Yeah. Me too, Mom.
All right. Well, now I got a crayon. Jeez, I can't win. All right. What about for B? Slope for B. Slope for B.
2 over 3.
Negative 2 over 3.
Yeah.
Slope for C. 1. Okay. Does everyone agree with those particular slopes?
Wait, but for B, I got 2 over 3 positive.
Oh, it's positive?
Yeah.
So the question is there? All right, so let's take a look. Letter B. I have 2 minus 4. 2 minus 4, so that's negative 2, right? And 0 minus 3.
Negative 3, and then that's, if you simplify it, that's 2 over 3.
Should be 2 over 3, right? Okay. Yeah, it should be 2 over 3. All right, what do we need? Determine which one of the lines are parallel, if any. I would say those 2 lines are parallel. How do I know?
Same slope.
Same exact slope. Okay? So remember, slope is what is it doing in the y direction over what it's doing in the x direction. So slope is, if we had something labeled, if we had like time, and we had temperature, and we had something like this, would you say it's getting warmer as the day goes on? Or
Yes.
warmer as time goes on?
Yes.
Yeah. So remember this, you are going in this direction first, and then you're going in this direction. So if I were to have something like this, and let's say we found this to be a slope of 2 over 7. I don't know, I'm just making this up, right? What does this slope mean in the context of this problem?
It goes up 2 units in the temperature for every 7 units in the temperature.
There you go. So it goes, the temperature goes up 2 units. Now if I said temperature in Fahrenheit, then it would go up 2 degrees Fahrenheit. And time is in hours. As 7 hours passed. As 7 hours passed. I like it. That's that slope in the context of this problem. I talked about what happened in the y direction over what it did in the x direction. Okay? So again, and that had nothing to do with problem number 1. Hi. Okay. Cool. So these are parallel because they're the same slope. 2/3 is close to 1, but it's not the same. That's Wyatt. That's for you. Corey, that's for you. All right, number 2. Number 2, help me out. Help me out on number 2. We have this. We have this. And we have this. Correct? Can we set, do we know what the slope is on any of these?
No.
At this point, do I?
No.
What do I have to do?
Divide by
Solve for
2.
y.
Yeah, this one I have to divide everything by 2, so I get y equals 1 over 2x. Shh. So this has a slope of 1 over 2. Agree?
Yes.
Then I have to solve this one, so I get this. Is that right?
Yeah.
And then divide everything by 2.
1 over 2.
That gives me a slope of 1 over 2. And then this one, I got to go divide everything by 2. So what's the slope of this one?
Negative 1 over 2.
There you go. Quick question. I can tell you that this is parallel to this. Why do I know that? Because they're the exact same slope. Is this slope perpendicular to that, though?
Yes.
No.
Yes, it is.
No. It's
No, no,
negative.
no.
It is not. It's negative sign, but it's not the reciprocal. It's not the flip over the fraction. It would have to be negative 2 for a slope. Make sense? So these are parallel. This is not going to be perpendicular because it's an opposite sign, but it's not the opposite reciprocal.
So it would have to be 2 over 1.
That's it. All right, problem 3 and 4. Write an equation. So we talked about this quite a bit. Now I want to work this out. We want to write an equation. So remember, if it just says, hey, write an equation, we have 3 linear equations to choose from. Well, I know on this one, I know that my slope is 2, and we wanted the parallel slope, right? Okay. So I'm going to label this x1 and y1, and I'm going to use my point slope formula. Right? Bless you. Is this an equation? Is this an equation?
Yes.
Yes. Should I go any further on this problem?
No, you should leave it so you know
Yeah. Okay? So it just asked for an equation. It didn't ask for anything different. It just asked for an equation. Okay? If it said, write an equation in slope-intercept form, that means we would have to solve it for y. But right now it just says, write an equation. Okay, problem number 4. What's the slope of this equation? Negative 4. And then I want to write an equation, so that's x1, y1. I'm going to use my point slope. So I get y minus 1 equals negative 4, x plus 2. Good. Could I have written it minus minus 2? Absolutely. Okay, I was just reducing signs. Again, it asks for an equation. Yeah.
If you did minus 2, would that be correct?
Yeah, I would give that to you. Number 5, determine which lines are, if any, are parallel or perpendicular. So number 5, I have A, B, and C. What is my slope for A on number 5? Shout out.
Negative 4/3.
Negative 4/3, thank you. What is my slope of letter B? Shout out. My slope would be 3 over what?
Negative 3.
I got
4 minus 1, 3.
I got 3 over 4.
3 over 4 I'm getting.
Oh, yeah, 3.
Okay, and then letter C.
0 over 3.
Careful.
Really?
Negative 4.
So 2 minus 2, 0. How? Oh.
Negative 2 minus 2 is negative 4. 3 minus 0 is 3. Where are my parallel ones?
Negative 4/3 and negative 4/3.
Okay, so those are my parallel. And then this, those are perpendicular. Perpendicular. Are these? Yep. So, that works. Does everyone see negative reciprocals taking place? Meaning opposite sign, flipped over fraction to decipher parallel or perpendicular. Okay. Number 6. Line A has a slope of negative 4. Letter B has a slope of, oh, shoot. Let me work this out. X minus 2 equals 4y. I think I did that right. So that is a slope of 1/4. And then letter C, we have, let's see, I'm going to work this out. Plus x equals 3. Negative 4y equals negative x plus 3. Divide everything by negative 4. Yeah, it is. It's 1/4, isn't it? 1/4 x minus 3/4. So this has a slope of 1/4. Okay? So this and this are parallel. Yes?
Yes.
This is what to this and this? Yeah, those are perpendicular. We use the upside down T. Cool? Can everyone see negative reciprocals there? Sometimes negative reciprocals are harder to see when you're just talking about a whole number, but -4 can be written as -4/1, correct? Opposite sign is then positive. Reciprocal means I'll flip over the fraction. So -4 flipped over is 1/4. Opposite sign, positive. Done. 7, write an equation. That's key. That's perpendicular. What is my slope of this line? 1/3. So what would the perpendicular slope have to be?
-3.
-3. Could I put -3/1? Sure. So this is the slope I'm worried about, okay? Because it wants an equation that is perpendicular and also goes through that point, okay? So I'm going to use my point slope. That's x1, that's y1. So I get y minus -3, which is y plus 3. Am I okay there? Then I'm going to go -3.
X minus 2.
They wanted an equation. We have an equation. This equation happens to be perpendicular to the given equation. So it's perpendicular to this. So if I drew the two lines, they would intersect each other, crossing at 90 degrees. And we have that particular slope and goes through that point. Number 8. Number 8, I have this. Then I have this as my. So what is my slope of this line? -3/5. So the perpendicular slope is what? 5/3. Agree? So that's the slope I want to use. Agree? So I got x1, y1. You get y minus y1 equals m times x minus x1. Cool? So I get y minus 1 equals 5/3. Why am I using 5/3? What did I ask for?
Perpendicular.
Perpendicular. There you go. So here we are. It is all done. What do you think? This doesn't seem too bad.
I don't get it. How do
Really?
you find the slope?
You have to just
Are you serious?
use the equation.
No, I know that, but how do you find the slope on number 9?
Oh.
I couldn't find 2 points.
It's a good thing that I'm going to work it out for you, sir. But I like it. It was funny. It's like, you answered every question on the front. When you said I don't get it, I thought you were joking.
Oh.
I was like, what? All right. Let's take a look at number 9. So number 9, I'm going to put a graph. I'm going to put the Cartesian up. So I think we have a linear equation that is about, let me do this orange. I'm going to just kind of draw this in because I don't know.
It goes like halfway between 2 equations.
So that's kind of what we have there, right? Write an equation of the line that passes through the given point and is parallel and perpendicular. All right. So I think on this problem, 4, 2. We have that point right there, which is 4, 2. So I think what they're trying to do on this problem, boy, you know what? I have to think that they were meaning
There's a point at 2 over 1.
1, 2. You think?
Yeah, there's a point there.
And on your thing? Yeah. Okay. So I think. I'm just trying to make my best guess. Being that the grid didn't graph, I think this point exists for you, and I think this point exists for you. And if it doesn't, let's go ahead and make them exist on this graph. Is that okay? Again, your graph, you might not have a nice grid that you can see, but I think that we can assume that this point, and if we're not, and this point, I think both of those could work for us on this problem. Okay? So let's find the slope of those. So I'm going to call this x1, y1, x2, y2. What was the slope equation? I forget. Equation y2 minus y1. Okay, so let's figure out what the slope of that line is. So I have 2 minus 5 and 1 minus 0. What's that, negative 3 over 1? So negative 3. So this is what we want. We would like to find, and I'll do the parallel in the purple. I want to find the equation that's parallel to this line that goes through this point. So technically this would be a line that's doing kind of this, right? Oh, kind of, if I could draw something like that. Okay, so parallel means I'm going to go y minus y1 equals m times x minus x1. So I'm going to label this point now x1, y1. I'm ignoring those were labeled. I know the slope of those. So now I want to know, plug these points in. So I'm going to take my y minus y1, y minus 2 equals negative 3 times x minus 4. So this equation right here is parallel to the orange line, even though we had to superimpose the new dots in there. It also goes through that point. If I want to find the perpendicular slope, what's the perpendicular slope to this? 1/3, and it's positive, right? Cool? All right, so then I'm going to go y minus y1, so y minus 2 equals 1/3 x minus 4. So this line is perpendicular. This one was parallel. Parallel one, perpendicular one. And it contains those points. So I agree with you, Ron. This was a tougher one. We had to make up points because it's not as clear as it should have been. I'm sorry about that. You what?
Is it easy to define the slope like when you're identifying the slope, isn't it just the same if you change to like find? Never mind.
Well, I hadn't found the slope. I didn't find the equation of the orange line. I just found the slope, right? Number 10, we got to do our best guess on number 10 as well. Number 10, let's see what we got. Math, graph, Cartesian. Shoot, the only thing I really know so far is 2, negative 2. Agreed? I think our equation is going to contain 2, 2 there.
And then it passes it like 1. X-intercept.
It kind of goes in between though, it looks like.
Yeah, that's about
So I'm just going to do this. I'm going to say, let's call this our other point. I might be off a smidge, and I apologize. But let's say that's our equation. Okay? So let's say this truly is our equation. Could I find the slope just by counting down and left? Can I find the slope?
No, because
I go
there might be other points.
1, 2, 3, 4, 5, 6, 7. Down 7. Agree?
But there might be other points though, in between.
Okay. 1, 2. It doesn't matter. Any 2 points, it doesn't matter how far apart they are. If we choose too far, we can reduce, right? So if you had this line like this, and you knew this point and this point, but the person next to you chose this point and this point, it's going to be the exact same slope. It's just that if you chose the ones too far away, you would have to reduce it, and it still comes out the same. Does that make sense? But it's a great point. So with what we know, we went down 1, 2, 3, 4, 5, 6, 7. Went down 7, so that was negative. And then I went left 1, 2, which is also negative. And negative over negative is positive. Agree?
Yes.
Okay? So I know my parallel slope has to be 7 over 2. And let's use this. I'm going to call that x1 and y1. So to find my line parallel, y minus y1 equals m times x minus x1. And then y minus 1, so y minus minus 2, y plus 2 equals 7 over 2, x
minus 5, or x plus 2. Or x minus 2.
x minus 2. Okay, so this one happens to be the parallel line to this. And then this one, the perpendicular slope is negative 2 over 7. So I get y plus 2, which is minus minus 2, equals negative 2 over 7, x minus 2. Good? Okay. Numbers 11, 12, and 13. Determine whether the statement is sometimes, always, or never true, and explain the reasoning. A line with a positive slope and a line with a negative slope are parallel. False. So this is a never. Okay? So lines with the exact same slope are always parallel. But if I had something with a positive slope and something with a negative slope, those could never be the same because they're opposite signs.
If we're going left to right, yeah, okay, I see.
Gotcha. A vertical line is perpendicular to the x-axis. So a perpendicular line is perpendicular to this axis. What do you think?
Yes, it is.
So that's always true? I like it. Always true. Two lines with the same x-intercept are perpendicular. Two lines with the same x-intercept are always perpendicular. Well, I could do this, and I could do this. Are those perpendicular? So I would say this would be a sometimes true, because definitely I could have a line do that, and it's perpendicular, right? Cool. So that should give you a pretty good feel for our information. Yes? So let's hold on to that, because what this form will do is help you. This is what I would like to do between now and the end of the period. Okay? So we are going to work on the review, which is page 121. 121 and 122. There are still a couple of you who had not finished the Schoology. So some of you haven't finished that, so I can open up the Chromebook cart for you if you need that. Okay, hang on. Shh. So this is today.
Wait, what's our homework?
So this will be checked off on Monday. Now, Monday next week, we will check off that homework, and we have another review that we will work on Monday. And then on Tuesday next week, we have a quiz.
Wait, when's our? Oh, no.
Our test is
What's it? Oh, I read it mine.
You're dumb.
a while away.
Oh.
It's after Thanksgiving.
What is this Tuesday?
Huh?
Like a final or just a test?
Just a chapter test. It'll be after Thanksgiving.
Technical?
Cool. Yes.
Pencil.
Not ready.
Wait, is next week?